The sigma plus particle can decay into a pi 0 particle and another particle y as shown in the Feynman diagram. Identify the exchange particle X. We can see that in a given reaction, strangeness is not conserved because there is a strange quark before and there are no strange quarks or anti-quarks after. And it's possible only for the weak interaction, and possible exchange particles are W plus, W minus or Z0. And to find out which particle is here, we can consider any node, for example this node, and charge must be conserved. It means total charge in should be equal to total charge out, and charge of S quark is negative 1/3, charge of U quark is 2/3, and hence negative 1/3 should be equal to 2/3 plus X. Hence charge of X is negative 1. Hence exchange particle X is W minus. W minus. Identify particle Y. You can see that the structure of Y is UUD. It's a baryon, and let's consider charge. U has a charge of 2/3, so 2/3 plus 2/3 minus 1/3 is plus 1. So a baryon which is positively charged, it's a proton. So Y is a proton. Outline the nature of the pi 0. We can see that it consists of quark and anti-quark, and it means that it's meson. And also it has 0 charge, so we can say that it's the neutral meson. And if we consider the antiparticle of pi 0, we can see that it will also have structure UU hat. So we can say that this particle is own antiparticle. And the next question, the pi 0 particle can decay with the emission of 2 gamma rays, each one of which can subsequently produce an electron and a positron. State the process by which the electron and the positron are produced. It's called pair production. Sketch the Feynman diagram for this process. It looks like this. Time, let it be to the right. Gamma ray and electron, its particle, so arrow is in the same direction as time, it's electron, and positron. Positron is an antiparticle, so it must be in opposite direction. And the next question, discuss whether strangeness is conserved in the decay of sigma plus particle in A. It is not conserved. Strangeness is not conserved because strangeness before is equal to negative 1 before and is 0 after. Each strange quark gives a strangeness value of negative 1. And there are no strange quarks or anti-quarks after, hence strangeness after is 0. And that's all for this question.